Okay, so a quick titration here. The first thing I would always encourage you to do is to annotate your equation. So we need to know the number of moles, concentration of volume, NCV. So that's for the nitric acid, and for the sodium hydroxide we can do the same, NC3. So first things first, just have a look through the question, see what data is available to you. So a student carries out titration to determine the concentration of a solution of nitric acid. So that's what we need to know, the concentration. We don't know that. So we need to know N and V, the other two parts. So she titrates a solution of nitric acid against a standard solution. Standard means you know the concentration of sodium hydroxide with a known concentration of 0.0998 moles per decimeter. She finds that 21.8 centimeters of the nitric acid, so I'm going to put that in as 0.0218 because I've divided it by 1,000 in my head, because we have to put it, because this is decimeters, the concentration, we have to put the volume in, we can't put it in as centimeters cubed, we have to put that in decimeters as well. So you divide by 1,000. So 21.8 of the nitric acid is needed to neutralize 25 of the sodium hydroxide. So that's 0.025. So we just annotated it, and immediately we can see that on this side we've got two parts of the equation. So N equals CV, so 0.0998 times 0.025. That gives us I'm just going to round up slightly, 2.5 times 10 to the minus 3 mol, moles. Okay, so 2.5 times 10 to the minus 3. Now, if you look at the coefficients, the numbers, there's an imaginary 1 here, and there's an imaginary 1 here. We don't draw them in chemistry, we don't put the ones in, but they are there. So that means that the sodium hydroxide and the nitric acid react in a 1-to-1 ratio. So we've also got 2.5 times 10 to the minus 3 moles of acid. So now, if you focus on this side, we need to work out C, and we've got the other two parts of the equation. We've got N and V. So C equals N divided by V. Just rearrange the equation. So it's 2.5 times 10 to the minus 3 divided by 0.0218 gives us a final answer of 0.115 moles per decimeter.